Let's take a look at problem number 12. With the given function here, find the value of v that maximizes capital T. So that's a matter of finding the derivative, t prime. So that's the derivative at the top times the bottom minus the top times the derivative of the bottom, which is 4v cubed, over the bottom squared. And we need to set that derivative equal to 0 to determine where the function we think is going to be maximized. Okay, so here we have 10,000 minus 40,000 v to the fourth, and here we have 3 times 10 to the eighth. So we have minus, well, I can factor 10,000 out. And that leaves me 30,000 minus 3v to the fourth over the denominator, which I'll just simply copy over the denominator. And therefore, the fraction is equal to 0 if and only if the numerator is equal to 0. And so because v must be a positive number, that means v must be equal to 10 in miles per hour. So 10 miles per hour will be the value of v that is the maximum. Then plugging in 10 would actually give us the maximum speed. So t of 10 plugging in 10 gives us 100,000. 10 times 10,000 divided by 30,000 plus 10,000 for 40,000. And so the maximum speed works out to be 2.5 miles per hour. Finally, one last detail that's left is confirming that this is indeed the absolute maximum. So let's think about the graph of t prime, both to the left of 10 and to the right of 10. So clearly, t prime is equal to 0 when v is equal to 10. If I plug in a number that is less than 10, I get something that is positive. And if I plug in something into this that is greater than 10, then the numerator is negative, and also the denominator is always positive, so negative. So that means the graph of t increases to 10 and then decreases to the right of 10. It is the only critical point, and therefore we can say with absolute certainty that this is indeed the absolute maximum of the function.